Hello, my name's Andy Connell and you're watching a screencast on software testing. Within this screencast we're going to be considering the fundamentals of testing, specifically what's its purpose and how does it fit into the development life cycle. It'd be useful to think to start with about how failure occurs. Failure occurs because of defects inside the system. Defects occur because errors have been made when building the system. This should not surprise us. To err is human, and it's still humans that build most computer systems. But there can be many reasons as to why errors occur. Complexity, inadequate training, ridiculous deadlines. The list is longer than the one I'm showing here. The consequences of failure, the obvious consequences are loss of things like money or perhaps business reputation. But project failure itself can be a lot more serious than that. Consider what would happen if an operational air traffic control system failed for whatever reason. This diagram, the resourcing triangle, is a very famous diagram. What it considers is the relationship that exists between these three elements: time, money and quality. Everybody wants a computer system which is cheap, delivered quickly and is of high quality. However, if you want it cheap, it's going to impact on the timeline and it's going to lower the quality. If you want high quality, then it's going to take time and it's going to cost money. Whichever corner of this triangle you squeeze, you're going to impact on the other two. When considering testing, it is important to recognize the fact that you can't test everything. The second thing to recognize is the fact that different parts of the system will have different risks associated with them. Recognizing those risks is a good way in which to start structuring our tests. We can't test everything because resourcing is finite. There's only so much money, there's only so much time. So what we want to do is get the important tests out of the way first. The important tests will be those tests which test those parts of the system which are high risk. The test process itself, a bit like the systems development life cycle, proceeds as a number of steps. First we plan, then we do the analysis and we design our tests, then we execute our tests and consider the results we get before finally closing down the testing activities. So just to reiterate, first we plan, then we design, then we execute, then we look at the results, and we close down the testing activities. Now let's consider the testing process against the systems development life cycle, the classic waterfall approach of feasibility, analysis, design, then we build it or code it, and then we do the testing. We execute the tests at this stage, and then finally, of course, we will then implement the project, i.e. make it go live. We take those steps, and ignoring feasibility, we go through the steps of the system development life cycle of analysis, business design, technical design, program design, and finally build or code. Now, I said before that in the previous slide that testing occurs after the build. It occurs after the build, but we can start planning the tests beforehand. Testing as it relates to the individual program is something which is called unit testing. It comes straight off the program specification. Take unit testing up a level and we have modular testing. This comes from the technical design, sometimes called integration testing. From the business design we can start to produce system test plans, and from analysis, which is the capturing of requirements, we can start to create user acceptance tests. So we can see that the actual planning for the testing process can begin quite early in the systems development life cycle. However, we don't execute those tests until the end. Now, I've been talking about the systems development life cycle as a methodology, and it's still quite commonly used methodology, but there are others you should be aware of, such as the agile prototyping methodology, sometimes called a RAD methodology, and the idea of process re-engineering an existing system. This too will require testing, and how the testing fits into these two latter types of development methodology is slightly different from how it fits in to the SDLC. Now let's think about the categories of the types of tests that we've got. We've got a kind of test which is sometimes called black box testing, specification based testing. It concerns itself with inputs and outputs. not too concerned about how the data is actually derived. The type of testing it does concern itself about how the answer is arrived at is sometimes called structure-based testing, also known as white box testing. This is a very technical form of testing. It's making sure that things like all the program code can be executed under some circumstances and there's no redundancy. Make sure that standards are complied with. Issues like that. Finally, we have the idea of experience-based testing, where users can use their experience of the business to improve the system or test the system to ensure it's fit for purpose, ensure it's compliance. This ends this particular screencast. Thank you very much for listening.